Okay, in the second tension review question, to build on from the previous question that we had here, when the two blocks were attached by a rope of 1 kg, and the blocks are still 5 kgs and 3 kgs, but now we change the rope to a much lighter rope, that it's only 1/100th of the previous mass, so it's only 0.01 kgs. But for this question we just want to figure out how large must the pushing force be in order for the blocks to have the same motion as 1 kg, the 1 kg rope. So the system with the 1 kg rope, we knew the acceleration was 0.5 meters per second squared. So if we want the system with the 0.01 kg rope, we want that to have the same acceleration. So the pushing force, because the surface is frictionless, the pushing force is equivalent to the net force on the system. So F net on the system is equal to F on the system by the hand, and that's the mass of the system times A. So in this example, the force in the system by the hand, mass of the system is now considerably lighter, so it's 5 and 3 is an 8 kilogram block system plus this 0.01, so the mass of the system is 8.01 kgs, and then we want that to have half a meter per second squared. So in this particular case we want half of 8.01, so F system at hand, so that will be 4.005 newtons. Okay. So that's considerably slightly smaller. So in the previous case we had the hand pushing with 4.5 newtons. So if they change the mass of the system and you want the system to have the same acceleration, it's not possible for the hand to push in the same way. So in this example, so again, if we go to 1/100th of the mass, we've changed the mass quite a ways, but we want the systems to have the two cases to have the same acceleration. So the hand has to switch up its forces, so it has to change to 4.005 newtons, so just slightly over. And I know this is sort of violating a significant sig fig issue, but I wanted to keep the extra sig figs for the next part of the problem that's sort of getting to a bigger point about thinking what happens to tension forces on the end of the string when you begin to change the mass of the string. So sort of slightly ignore the issue with the sig figs just for now.